In this video, we're going to be taking a look at writing equations from tables, and the essential question is how can you use an equation to show a relationship between two variables. Now you'll need to have your Go Math book out, turn to page 345, your math journal, and a pencil. So let's take a look at the Explore activity on page 345. It says writing an equation to represent a real-world relationship. And it says many real-world situations involve two variable quantities in which one quantity depends on the other. We talked about dependent variables and also independent variables in the previous lesson. So this type of relationship can be represented by a table. You can also use an equation to model the relationship. So we're going to take a look at this on page 345. It says a table shows how much Amanda earns for walking 1, 2, or 3 dogs. It says use the table to determine how much Amanda earns per dog, then write an equation that models the relationship between number of dogs walked and earnings, and use your equation to complete the table. So we can see for the first one, the dogs walked, one dog walked $8, 2 dogs 16, 3 dogs $24. Now we can see for letter A, it says for each column compare the number of dogs walked and earnings, and then what is the pattern. So you can see easily with one dog earning $8, 2 dogs 16, 3 dogs 24, we can see the pattern. Each earnings amount is 8 times the corresponding number of dogs walked. So knowing that, we can see based on the pattern, Amanda earns $8 for each dog that she walks. Now we want to write an equation that relates the number of dogs Amanda walks to the amount of earnings, okay, that she earns, or the amount she earns, and we're going to let E represent earnings and D represents dogs. So remember, an equation is a mathematical statement that two expressions are equal. So we're going to write an equation here, and we can have, and I want you to do this with me, we can have dogs D times 8. Why is it times 8? Because it's $8 per dog equals the earnings, which is E. Or you could also have E equals D times 8. Any of those would work. All right, now we're going to use our equation to complete the table for 5, 10, and 20 walked dogs. So we know if it's $8 for each dog, 5 times 8 will give us $40. And it's important to understand with these tables, you have to make sure you see the number of dogs walked, because it's very easy to say, okay, 4 would be the next one, but you can see they skip 4. The next one is 10. So if it's $8 per dog, $80. 8 times 10 is 80. $20 times $8 is $160. Hopefully Amanda is not walking 20 dogs at one time. If she is walking 20 dogs at one time, probably the dogs are walking her. So we can see that for letter D, we can complete the table. And then we can see, thinking about independent and dependent variables. Okay, so we know that Amanda's earnings depend upon, we can see the number of dogs that she walks. Okay, for the amount of number of dogs she walks, as that increases, you can see the earnings increase as well. So Amanda's earnings depend on the number of dogs walked. We'll write that out together. Okay, so let's take a look at the reflect section. It says, what if Amanda changed the amount earned per dog to $11? What equation could you write to model the relationship between number of dogs walked and earnings? So we know that the earnings, the E, will still stay the same. And then instead of the 8, we're going to do the 11. E equals 11 times D, or 11 times the number of dogs that she walked. So the only thing that would change would just be the 11 would replace the 8, because $11 per dog instead of $8 per dog. So now let's take a look at page 346. It says write an equation based on a table. It says the relationship between two variables where one variable depends on the other can be represented in a table or by an equation. An equation expresses the dependent variable in terms of the independent variable. When there is no real-world situation to consider, we usually say x is the independent variable and y is the dependent variable. So with a real-world situation, we would know that dogs earned would be x, and then the earnings would be y. So x would be the independent variable, y would be the dependent variable. So let's take a look at an equation that represents y in terms of x. Let's take a look at example number 1. So we can see x, we have 1, y equals 5/10. X is 2, y equals 1. X is 3, y is 1.5. So what we need to do first of all is we're going to compare the x and y values to find a pattern. So we need to find a pattern. All right, so we can see each y value is 1/2 or 5/10 times the corresponding x value. So in other words, a half of 1 is 1/2. 1/2 of 2 is 1. 1/2 of 3 is 1.5. 1/2 of 4 is 2. 1/2 of 5 is 2.5. So you can see that the pattern has to go throughout the whole entire table. You cannot just look at the first one and then develop a pattern. It has to be consistent throughout the table. And then use a pattern to write an equation expressing y in terms of x. So in other words, y, which is the dependent variable, equals 0.5 or 5/10 times x, which is the independent variable. Okay, so y equals 0.5 times x. So that could be an equation that we could write. Remember, x is the independent variable and y is the dependent variable. So whenever we're writing equations, y will always need to be alone, and then you'll have whatever pattern you see multiply or added or whatever the pattern is that you see to that variable of x. So let's take a look at another one. We have x is 2, y is 5. So we're going to compare the x and y values first to see a pattern. So then I see 4. What happens to 4 to make it a 7? What happens to 6 to make it a 9? What happens to 8 to make it an 11? That pattern has to be consistent. So I can see that I'm adding 3 to each x value, or I could say that each y value is 3 more than the corresponding x value. So we're going to use the pattern to write an equation. So we have y, once again, as the independent variable, equals x, the dependent variable, plus 3. So that's the pattern that we have. Y equals the independent variable plus 3. Why do we know that? Because every time we see our x, 3 is added to each one to get the y. So let's take a look at number 2 together. Let's take a look at number 2 together. And we have, first of all, we're going to compare the x and y values to find a pattern. So 12 to 10, 11 to 9, 10 to 8. You can see 2 is being taken away from each x value to make it a y. And so what we're going to have y, which is the dependent variable, equals x, which is the independent variable, minus 2. So y equals x minus 2. Now what I would like you to do is number 3. You can work on that independently. You can work on that now. So the answer for this problem is y equals 2.5 times x. Now let's take a look at number 4. And I'd like you to work on that now. Okay, so we have the answer y equals x plus 5. Now let's just take a look at number 5 really quickly. And we can see that the first x and y is 0 and 0. Do not let that trip you up. You just need to look at the next x and y within the table just to make sure that it has a pattern. So we have 1 and 2, 2 and 4. You can see that the x is being multiplied by 2 in order to get the y. So that would just be y equals 2 times x. So don't let those two zeros for the x and y fool you or trip you up or anything like that. Okay, let's take a look at page 347. It says using tables and equations to solve problems, and it says you can use tables and equations to solve real-world problems. Now this is an example that you can see, and these are certain steps that you'll need to take to solve these real-world problems. So you want to analyze the information, formulate a plan, solve the problem, and then also justify and evaluate your answer to see if it is correct. So I do want you to read through page 347. You can refer back to these certain steps that you can see to solve these types of problems using a table and also an equation to help you out. Now, read through that. Just pause the video and read through that, and then we'll take a look at number 6 together. So I'd like you to pause the video and read through page 347. You can do that now. Now let's take a look at number 6 on page 348. We're going to take a look at what we did on 347, or what was shown to you on page 347, and then write out a table and also an equation to solve the problem. So it says when Ryan is 10, his brother Kyle is 15. When Ryan is 16, Kyle will be 21. When Ryan is 21, Kyle will be 26. Write and solve an equation to find Kyle's age when Ryan is 52. So we need to analyze this information. So we know we're talking about Ryan's age compared to Kyle's age. And then we need to figure out the relationship that we see. So since we're dealing, first of all, with Ryan, we'll write Ryan at the top and also Kyle underneath. Okay, we know that Ryan is the independent variable, Kyle is the dependent variable. So we know a couple things, that Ryan is 10 years old, and then when Ryan is 10, Kyle is 15. When Ryan is 16, Kyle is 21. When Kyle is 21, Kyle will be 26. So we can see that information, and now we need to take a look at how we can solve it. So we can see every time we go from the x to the y, so 5 is added each time to Ryan's age. So 10 plus 5 is 15, 16 plus 5 is 21, 21 plus 5 is 26. Now, knowing this, what we can see the equation, which is Kyle, K, equals Ryan's age plus 5. And that pattern is throughout the whole table. So knowing that Kyle's age equals Ryan's age plus 5, what we can do, we can plug in the numbers. Ryan is 52. And we know that the equation is 52, or the Ryan's age plus 5 equals Kyle's age, which will be 57. Okay, so they're asking us the answer, write and solve an equation to find Kyle's age when Ryan is 57. So we wrote the equation, and then we can also write the final answer. How old will he be? We can say 57 years old. And you can see we already justified that in solving the problem. In other words, we plugged in numbers for our equation. So Ryan's age plus 5, 52 plus 5 would equals Kyle's age when Ryan is 52. Now let's take a look at number 4 together. It says write an equation to express y in terms of x. So we have not really done a division. We didn't really do a division problem throughout the video. So we can see 12 is divided by 6 gives us 2. 24 divided by 6 gives us 4. 36 divided by 6 gives us 6. So what we can have, we're going to have y equals, and we know we can see is x divided by 6. Okay, so in other words, x, we can plug in the numbers 12, which would be x, divided by 6 would give us 2. So the equation y equals x divided by 6. So I wanted to show you that problem in the video. Now what I would like you to do is number 5, complete that whole problem, and when you're finished I'll have the answer for you. So I want you to work on that now. Okay, so you can see for number 5, the number of songs equals n, cost equals, and we can see that cost equals $1.35 times n. That would be the equation. And then what's the total cost of 25 songs? We take $1.35 times 25 gives us $33.75. Now let's take a look at the essential question check-in as we wrap up the video. It says explain how to use a table to write an equation that represents the relationship in the table. It says compare the x and y values to find a pattern. Use the pattern to write an equation expressing y in terms of x. So this concludes the video on writing equations from tables. If you have any questions about this concept, please come and see me.